Hello and welcome to another episode of Hacking with Friends. Today I have my friend Michael here, and my name is Cody Kinsey, and we're going to be going into a little bit more about what we covered last time, which is using APIs. Although the last time we were actually shooting, our production assistant here was freaking out because he felt like we were leaving out some really exciting, really cool things about APIs that we weren't showing while we were building our OSINT tool. So after checking and finding out that actually, there were some things that we left out that we could have gone into, we're going to explore the topic a little bit more today and dive deeper into using APIs for OSINT things or building tools. But today, we're not just going to focus on publicly documented, really easy to access APIs. That was the easy stuff we did last time. Today, we're going to take the step of actually going after APIs that may not be public or may not be documented. And Michael here is going to explain a little bit about the difference between those.
Yeah. So there's, so just recap a little, just an API or application program interface is essentially the way an app on your phone, for example, will communicate with the server backend. If you wanted to think of us as computers, the English language would be our API. It's that standardized way for us to communicate together. Now, those APIs sometimes are documented, such as y'all covered, particularly, with like government data, like cities. That's a very popular thing for cities to do, is make their API data publicly available. That's where you get apps like City Mapper or like other transit apps that'll help you find like the best bus to take or something like that.
By the way, did you guys know that apps like City Mapper and those other apps actually use public data from these cities where they have GPS trackers in all their buses, and then the city makes a public API available that developers can build on top of in order to make like transit apps for consumers and things like that. So this is heavily used by developers and other people who want to just create a service based on data that's already out there. So it's really cool because if you have an idea and the data's out there, you can usually make a project that no one else has made before, at least with that data source.
Yeah, and it's particularly useful because when you get in that format, it's often like in JSON format. It's very easy to manipulate because JSON or JavaScript orientation notation or object notation. It is intended to be human readable, and we'll actually go into a little more about some of the JSON data types.
Well, I like JSON because it's really easy to program with. You can read it, and most browsers have plugins that make it really easy if you just have it sprayed on your screen to at least like figure out what's being shown to you. Where some other data types like CSV or whatever can just be kind of like jumbled and like be a bit confusing and might not also be able to be like nested in a way that makes sense or is easy for a human eye to read. So JSON's really good for that. And I again like it for programming in Python because it's really, really easy to parse and use in a Python library.
Yeah. And now, not everyone is as foresighted in making their APIs publicly available. Now, sometimes they have good reasons for that. There are various apps that you'll have on your phone, and their APIs were never intended to be seen by anyone else, right? So that's how they would control the way the user interacts with their apps.
So just to be clear, the server might have all these different actions that can be performed, but the application can only maybe perform some of them. But if you were to maybe figure out how this API worked, you could potentially do all sorts of stuff that the company never really intended you to do, but it's technically possible once you know how the API calls work.
And that's definitely something like I think it's possible too to do like SQL type injection attacks and stuff like that, especially with the less well-documented APIs. I don't really have as much experience with that. What I do have a little more experience with is just abusing the APIs in ways that oftentimes they're not as robustly secured or developed well. So, for example, there was one app that I was working on, and essentially their business model relied on the fact that you could only see a limited amount of data at any one given time. And they had two API calls to retrieve that data. One API call was just to get a big old list of like data around you. And then another API call was to get data about a specific object. Now, what they didn't realize when they developed their API is that their API call to get the single object would take a list. So I could actually put in a list of every possible object ID and I literally I tried it one time with over 10 million objects
Mm.
that I was trying to retrieve the full data for, and it worked. It just literally timed out the connection because it was so much data. My computer couldn't download it fast enough before the internet was like, wait, I think that's not responding.
So basically what you did there was you were able to scrape the entire network
Yes.
just because they allowed a certain type of data into an API call that really shouldn't have been there.
Right, right. So essentially what they should have been taking is just a single integer, but instead they took it as a list of integers, or which were like the object IDs. And so I was able to just make a little for loop that generated, 1 to 10 million as object IDs and sent it as a list.
And again, this is really exciting for beginners too, because if you haven't worked with APIs before, it's basically a machine-to-machine language. And if you can jump in there and figure out how these machines are communicating and then, maybe slip in something and part of the conversation, you can totally change the normal behavior of these relationships between, an app and then what it does or doesn't allow you to do.
Yeah. And that's one very good security lesson for any developers out there. Assume that your API is going to get discovered at some point, and you should build security in depth and always verify the API GET posts and other requests that are sent in. Don't just automatically assume that they're like true and trusted and valid and all that, because someone might be abusing your app, right? Users don't always treat it well.
Yeah, so let's abuse some apps, huh?
So that what I just described is a little more exciting than maybe what I'm going to cover today. What I'm going to cover today is a little more groundwork, basic. But I think what I'm going to cover is just a little Python tool I kind of built a while back. Just a little context. I was in the server market and I was looking at running essentially a bot farm for some computer games, and I was like, well, how much would it cost to actually like buy all the servers you would need to do that sort of thing? And I started looking around on eBay, but I was like, there's so many options here. I don't understand which is the best deal. Like, there's all these different parameters. How do I sort? So I started looking into something called Beautiful Soup. If you're familiar with web scraping on Python, that's a library for Python to parse HTML data or website data and then extract information there. However, it can be a little daunting, especially if you're not very fluent with HTML, because you don't understand what all the parts are, and
it's hard to select a specific area that you're looking for and not like actually go through everything that was tagged, which might not be accurate.
Right. And so I was originally trying to use Beautiful Soup to scrape all the server listings on eBay, and I was getting really frustrated. And that's actually when I made a little discovery of a website. And actually, I'll switch to my screen and show you that. Now, that little website was called LabGopher. And essentially what they did is they likely knew Beautiful Soup better than I did. I don't know that that's the method they used. But essentially, they made a website that did exactly what I was looking for. It scraped eBay for all of these server listings. However, when I got there, I realized I didn't really have the control over the data that I was looking for. Like, I get these beautiful, gigantic spreadsheets, like you're describing CSV files, but like, it still means fairly little to me. Like, I have some control here on like, price ranges and the number of CPUs and like basically the horsepower of the computer and the memory and stuff. But I didn't have any way to aggregate that data and be like, okay, well, these systems have the minimum memory I need and the minimum pass mark, and then take the pass mark and like compare that to the price so I get the best performance per dollar.
So you've then kind of figured out like what your formula is for a deal, at least for what you're looking for.
And we'll get into that a little later when I look more at the code. But so I now have a much better source of data than I did on eBay, right? So this is where we can kind of get into some of the really basic stuff you can do. So I'm here in Chrome, but you can also do this in Firefox really easily as well. You just right click and then there's the inspect. Some of you may or may not know about this, especially for like the elements tab. This is where you would like inspect different elements of pages, like
I like to swap out pictures. Like I'll just like swap out the logo of every website with a picture of Dick Cheney.
Oh, absolutely. No, like that's actually one of the examples that I first learned to use the inspect feature for.
Was Dick Cheney?
No, not Dick Cheney.
Okay.
But like when there would be images on a page and you couldn't just like right click download and you maybe need that image.
Oh yeah.
So you can just inspect and then you can find like I think there's some examples in here of just like where you have the images, or you can always like Control F, I think. Yeah, so you can like then like JPEG,
sure, PNG, whichever.
PNG, yeah.
So you can basically just find out where the image is coming from, how it's being served, or like what weird link they're putting behind.
And then it'll just be a little link to one of the web pages that hosts just the image. But what's important for us here today is maybe one of the tabs that people use less often, or at least are maybe a little less known, and that's the network tab.
Yeah, what's that?
So essentially what this will do is this just logs all the network traffic that originates from this tab you're in, right? So what we can do is we can reload this page, and then we see we got all of this stuff going on. And we even get this like beautiful waterfall up here, and we get all this information so we can see where it's loading like a bunch of JavaScript, and then there's one of those PNG examples and stuff like that. Now, this is where you can start looking for APIs and the way this website is interacting with its server in the background and stuff. Particularly for websites like this that have like big like chunks of data, like in spreadsheets and stuff like that, they're often going to use an API that goes back to something like a SQL database, which you may or may not be familiar with.
I think Tim touched on that a couple live streams
ago.
Oh yeah, if you're curious about SQL databases, check out our previous live stream with Tim where we were using PowerShell to actually extract queries from SQL databases, which was super cool.
And one of the beauties of APIs like this and working with it in Python and particularly using JSON is, it's useful to know SQL, especially if you're like trying to scrape a massive database, because then you can take in that JSON data and then put it back in a SQL database so you can reference it later more easily. But you don't really need to know any SQL if you just want to grab some data and analyze it and then spit out an answer. You need like a passing familiarity with Python, and particularly certain data structures such as lists and dictionaries, which are used in JSON quite extensively. So back to this, what you're really going to look for is towards the beginning of this waterfall. You can just drag left click over it to select, and you can go to type, and you can sort like by the type. Sometimes you'll see like JSON in here and stuff like that. But I just happen to know. Usually this just takes a lot of like clicking around, seeing like, okay, what's going on here? Because you can click left click on one of these, and then you can see the headers, the preview, the response, all of this sort of stuff. So these are all the requests going back and forth between the website. The one we're looking for today that is interesting is the one down here that's just like US/. And this actually happens to be the API the API call that it uses to retrieve all of this data, but that it's displaying over here. On the left side, the models, the shipping price, the Gopher grade, how good of a deal they think it is, the memory, etc. So you can actually go over here and see the response. Hopefully, yeah. So you can you should be able to immediately recognize that it's JSON. And a telltale giveaway for that is you'll see like this data right here. And it's always important to remember too when you're looking at JSON data that these curly brackets and the straight brackets are different.
Yes.
Yeah.
Yes.
The difference between a list and a dictionary. So if like I click on this, should pop up in a new tab the whole Respond. Yeah, there we go. So and as you can see by the little tiny scroll bar, this is a boatload of data.
What is that?
So this is literally every single server listed on eBay that has been aggregated by LabGopher.
Wow. Is that current? Like they're currently on eBay?
Yeah, it's current. Yeah, so like here, I'll just show you. I'm popping up too many. I clicked on it too many times. The computer was just being a little slow. But yeah, so you can just click on one of these servers, and yeah, see, we got like a $40 server. I think that is that's an auction.
No bids.
Yeah, that'll definitely go up in price a little. But yeah, as you can see, this is definitely not readable.
Or useful, really.
Yeah,
I mean, it's could be useful, but it's just too jumbled and it doesn't make
right.
sense.
And so this is where we're going to talk about some really useful tools. So when you are trying to analyze APIs and stuff, you often need to capture these API calls so you can analyze them. Now, in this case, we were able to just use Chrome, and it was really easy. But oftentimes, if you're like trying to analyze an app on your phone, it can be a little harder. Like there are programs like BlueStacks that'll run an Android emulator on your computer, and you can try doing stuff like that. There are also like Android apps you can run, like Packet Capture, which will try to just capture the packets locally in the same fashion that Google Chrome does here. However, I find that some of the tools, like the one I love is Postman, are much more useful because they have a really pretty interface and they're able to act as proxies. So essentially, like if I have an app that I want to analyze, I can set up a proxy with Postman and then connect my Wi-Fi through my laptop, and I'm able to analyze those packets as they're going to the internet. There are plenty of other options too. Like if you're familiar with like Wireshark and you kind of like that like style of interface, I definitely recommend Fiddler, which is useful for that sort of stuff. But I think one of the reasons I love Postman the most, besides the pretty interface, is the ability to do this, and that is, so now that I have like this API call here, I can just right-click, copy as curl bash.
Okay.
And then I can just open up Postman, go in here, import raw text, paste, continue, import. And now I have this whole request loaded into Postman. So I have like the headers that I can fool around with. Like this is a really simple API call. It's not even passing any parameters. So oftentimes you'll have parameters. Parameters might be like in my previous example of like I wanted to get one object, I would have like an object ID that I'm passing in the parameters or something like that. But with this, with just Google Chrome and Postman, you can easily go analyze the request and then copy it when you find one, and then you just click send, and I think our internet's being a smidge slow. I do have a tab where I already did this request, just as an example. And so you get the JSON back, but also in a pretty format. So
that's so much nicer to read than the way it was before. It looks terrible.
And so like, as you can see, there's quite a few lines here of text, but then I just can click on these arrows and I can see some of the data. Now, one of the particular reasons I wanted to choose LabGopher as an example to look at is it's a beautiful monstrosity example of a closed private API, because when you go up here and you click on the data, look at this. So these straight brackets mean a list. You get a list of basically strings and integers back. There's nothing telling you what any of these things mean. Like, so that's very abnormal for an API. And I have a couple other examples of just like APIs just for comparison. So this is an API from another website. RS Buddy, it's a video game thing. But essentially, what you'll often get back in JSON data is you'll get the main dictionary, and then you'll have, like, in the case of Lab Gopher, you'll have the data, and then CPU models, stuff like that. And so that way, when you're in Python, you can just say, okay, give me the CPU models, and it's just going to jump to that place. And this is much better example of what JSON and APIs normally look like. You'll have a dictionary within a dictionary. So, for example, we have an item here, item 2, and then we have a dictionary that is just, the ID, the name, Boolean value of whether it's a members only item, and then, like, other quantities. But the important fact is they're all labeled, right? Now, you're not always, that is virtually always the case when you have an open API, a public API, because it has to be well documented for everyone to use. But when you're working with closed APIs like LabGopher, you can do just a string like this because you, the programmer, know what all these values are for. But when I, Joe Schmo, am trying to manipulate your data, I don't know what the heck any of that means, right? So that's definitely it can be a challenge when you're trying to reverse these APIs.
So can you explain the difference between a closed and a undocumented API, or like one that's meant to be like not shared at all versus one that's just like not documented well? Like, what's the main difference?
So I think, so broadly, as I said, there's like open APIs. So this is very common, like we said, that with cities, a lot of big like platforms like Google Maps, Twitch, stuff will have very well documented APIs because the intent is that developers out there, programmers out there, will take that information and make something better with it. Make something that company themselves doesn't want to pay anyone to do, but they want to enable the success of others.
Got it. So it's building blocks for other people,
right,
and it's meant to be used by them.
And whereas a closed API is, for example, there, like, I just as a good example, I remember there was the Tinder API, and then, like, that was only intended for to be used on the Tinder app, right? But then there were a bunch of people who like reversed it and were like doing all kinds of manipulation of the data and like building neural networks that would like swipe for them and do all kinds of crazy stuff like that. But the main difference too when you get into closed APIs is, I would say, the size of the company, the size of the development. So, for example, if you have like a big app like Tinder, it's going to be very well documented because there's a lot of coders working on that. And so there's going to be a lot of people changing hands with that information. So they need it to be very clear and human readable. Now, when you get to smaller projects like this, like LabGopher, there's only 1 or 2 people at most working on this. So they can be as... I was going to say sloppy. It's not really sloppy.
It's just obscure.
It's obscure.
They don't want other people in the API,
right,
so why would they make it easy for them?
Exactly, yeah. And that is something you could do, although, like, in reality, like in a big project, you're just making your own life harder, because then you're going to be like, wait, did I index that as 3 or 4? Because that's one of the beauties and the things I think you kind of glossed over on the last episode with Tim, is the difference between the list and the dictionary. Because with the dictionary, like on this, I can be like, okay, give me item 2 members. Is that true or false? Very easily. But with LabGopher here, what I have to do is, since it's a list, I have to index it. So I have to be like, okay, well, give me the value at position 3 in that list, and then that's going to be equal to this thing, right? It's much less immediately human readable than converting a dictionary into like a variable.
Okay, all right.
If that makes all, we'll dig into some of this. So so like when you get stuff like this, I hate to say it, but you gotta try and like it's trial and error how you figure stuff like this out. Oftentimes you can fool around, do like one thing I would definitely recommend when you're trying to reverse an API and when you're intercepting like on Google Chrome and stuff is you start clicking every button and just click stuff, and then that way you'll find the different API calls that are being utilized. And so, for example, here, like, I can make some educated guesses. Like, if there's, like, a long number like this, generally speaking, that's going to be, like, some kind of identifier. And one of the ways I can test that, and I figured that one out, is just, like, when you click on one of these servers, if it loads here, you'll see there's a number up here in the URL. And if you take that length, it's the exact same length as this number. So we can immediately tell that this number must be the eBay identifier number, and they're just using that as an identifier in their own list of data as well.
Okay. So we're starting to tie something that's otherwise just a random string to something that actually makes sense.
Exactly. Now, that's like just the easy low-hanging fruit, right? From there, what you would have to do is, now that I know, okay, well, this, let's see, like, this one is number 2, whatever, I can like copy it, and then I can go back over here, and then I can start trying. Can I control F in this? Yeah, so I can control F in this, and so now I found one of these lists that corresponds to one of these servers I just clicked on.
Okay, so now you're starting to figure out more about the data structure?
Yeah, exactly. So what I'm trying to, now I can start looking at these numbers and be like, okay, what do these numbers mean? So that's where it just gets a little tedious, to be honest. Let's close that out so we can see more broadly. So yeah, so that's where like 6 gigabytes. So maybe like, I'm like, is there a 6 in here? Hey, there's a 6 right there, but there's a 6 down here too. So, and then there's a 6 here. So honestly, like the way I did this originally is I would just go through multiple items like this, and I would just write beside each number. I took out a notepad and just put like CPU question mark or memory question mark. I think I actually have that file here. Yeah, so this is what I actually was able to eventually
debugging
it. So some of these, like, I still was not 100% sure, and like also like a handful were like also given to you, because you remember data wasn't the only kind given to us. We did have 3 other dictionaries in here, and so that did help a lot. So for example, we had models here which covered, like, they had an integer value assigned to each different kind of model of server. But that's still only sort of helpful, because now I know a number for the server, but I don't know which number that is in this list.
Right.
Because there's a ton of numbers here. So that's definitely a problem when you're reversing APIs, is you can't, I mean, you could always try, but you can't rely on the fact that you can just be like, hey, Mr. Developer, what did you mean here when you're like, why is this 0?
Especially if it's closed.
Yeah, no, exactly. So it is a lot of trial and error, but luckily it should be fairly rare. It only, like, I was saying, like, when there's only 1 or 2 people really developing something, well, you see something like this. But anyway, back to the main point, and one of the other reasons that I love Postman so much is, I showed you just use Chrome. You can copy and paste a request once you fool around on a website and find it. And then there's this beautiful little button up here, the most beautiful lazy button ever, called code. And I don't know Java. I don't know Ruby or Node.js or C# or any of those programming languages. But with a little click, I can get all the code I need to make that request again.
Hmm.
So it really, really makes it easy. So like, I don't know Ruby, but apparently that's the Ruby command to make this request, right? So it makes it really, really stupid simple when you're trying to fool around to just do what I'm familiar with, which is Python, and I like the request module, so that I can just go there. And this is what y'all were working on, like typing out all of this stuff. And for me, it's to get to this point, to get to full on really beautiful Python code, it took 2 copies and pasted.
Because it's generating for you like a big cheater.
Yeah, no, I mean, it's using time wisely and being frugal with your time. You can literally just take this and then you can copy it, and let's just backspace. We can just paste it in here, and then we can run it, and we should get a, yeah, there we go. We get a response, which, as you can see, is just one really long.
Oh my god.
Yeah. And so this will get in. This is a little in the weeds. It's just like how like Python requests works and stuff like that. But like y'all were using the JSON library last time to decode. But like one of the beauties of the request library in Python is you don't even need the JSON library, right? So down here, by default, Postman just like prints the response in text. But you can actually just go and you can print JSON like that, and it's going to do the exact same thing, but it's actually just that the data is now JSON.
Okay,
format.
that's handy.
Yeah, so and then that's where we can start parsing that data if we wanted to. So I actually have the program here where I basically already did that to some degree. But if we want to replicate that, we can.
Yeah, how much time do we have?
We're about 30 minutes in.
Okay, so yeah, we got 15, 20 minutes. Let's see if we can figure out how to make this more useful then.
Yeah, exactly. So like first, one of the things I did is I took advantage of the fact that I'm given a dictionary here in the request. So because that's a curly bracket right there, that means that it's a series of it's a dictionary, which is like the word models has a list associated with it. So when I call models, it will give me that. Well, actually, I think in this example, models is a dictionary as well. So I have a dictionary. So then that means that if I call models, it's going to give me the models dictionary, and that it says, okay, if it's 2, then it's a del R310, right? And so that means that in my code, I can do things like this, where I take, so here I'm doing the importing requests. Request is a library. You need to import it. Really easily done. And then I have like basically the copy and paste of Postman here. And then I just made a variable data that I loaded the JSON response as. Now I can take advantage of those dictionaries and immediately just make some variables here, which are, models, CPU models, shipping costs, and then the data. And so that's all I did is like took the first layer of dictionary out of there, and I broke it up into its constituent components. So that way when I'm referencing it in the code, I can just do something that makes a lot more sense and say like, which of these models is it?
So you're just converting into something that's easier to work with.
Yeah, exactly. Yeah. And then, I assigned a couple of variables that I'll need later, just so I could like reconfigure my data. So I made a list where I could make a list of all the servers, and I made some max and mass pass mark score. So just a little context pass mark score is just a way to grade a CPU's performance, like how much horsepower it's got. Okay. And then a max memory score is the amount of memory it has. So then you can just do like basic loops, right? Like you can, so for each item in my data dictionary up here, I can loop over. And then this is where you have to rely on the indexes that you discovered, right? So I got my list here. And so I know that each item is basically just a list of these, right? So the thing with a list is it doesn't change order. With a dictionary, it can be resorted any which way, right? And as long as I just call like data, it doesn't matter if data is at the beginning of the dictionary or the end of the dictionary.
I'm going to find it by the key.
I'm going to find it by the key. But with a list, you have to like reference it by index it by its position, which means that position is very important. And so that's like, how you're able to then start parsing through that data. And it's just a tedious process of like, I definitely always recommend when you're working with APIs and stuff, always use try or like get data, because you cannot rely on the fact that it like there's going to be a quirk somewheres and then you get a key error like y'all did last time. So that's definitely something you can do just accept, but I typically try to avoid doing stuff like that. You want to just accept key errors. So that means if like that little dictionary item isn't there, then you can just like pass over it, as opposed to the problem with just using accept is like it could be like some horrible fatal error in your code and it would pass over it and you would never know that that's the problem.
All of that to say that if a field is missing, it will crash your code unless you add a try except.
Yeah, exactly. But yeah, so I just did some basic analysis here, and and this is the problem with like indexing, because like each 9 means nothing, right? But like each 9 would be like 10, so that's like the number of CPUs, right? It just gets tedious working with APIs like that. But essentially, I was able to just try loop over all of it, and I was able to do some basic comparisons like how much CPU horsepower am I getting for every dollar I spend, right? So like I had like some minimum requirements, like, okay, I needed to have at least, X number of gigabytes of memory, and then after that I want the best bang per buck that I can get.
Okay.
And so I basically just went through that, and I was able to compile a new data list, and I made sure that instead of just using a list, my new data was actually all labeled. So that makes it more human accessible. And then this is definitely something I recommend doing all along is make comments. You never know, like, I wrote this program like a year or more ago, and comments are really helpful when you're like, what was I doing there? Why was I doing that? Like, yeah. Moral of this whole live stream is document your stuff, or else no one will be able to know what the heck's going on. But yeah, I can just run this real quick just to kind of show y'all what I did here. Yeah, so it spits out a bunch of responses here. And I just had it basically say that their server name, and then the pass mark score, and then give me a link for opening the new browser, or I might have to copy it.
Cool.
Yeah, so it just gives me what it thinks is a good deal. And like, obviously, this is very specific to this case, but the point being, be aware of what's in a list and what's in a dictionary, and use that to your advantage when you're analyzing the JSON data. And then also, you might want to save it in a format that is more accessible for you to use. And then that gets more into like where if you do know SQL, right, you can do things like log this data over time. So then you can do things that the API itself could have never done, right? Like, for example, I could log these servers over time and see historical data and be like, okay, this is a good deal now, but was this is this a good deal, or is this like all the servers spiked the past month because of the virus, and this is actually a horrible deal for a year ago. You and that's really the beauty of taking advantage of some of these APIs and doing stuff yourself. Yeah. But I think that's the majority of just kind of what I wanted to make sure that we covered in today's live stream. It's just some of that basics of breaking down an API and getting it into Python where you can get your hooks into it and start fooling around with it.
I really appreciate that it gives you code examples that are already pre-populated.
Yeah.
First, doing it in the browser where you're able to save an API response or call as just a curl request. That's really useful. And second, being able to take that curl request and then just put it right into Postman and then pull more code out of it. That's also really, really useful.
And again, this was a very basic API call, but the beauty too is in Postman, you can edit the parameters. So you have your key and value. So this would be object ID here, and then the value would be the eBay number or something like that in a lot of APIs. And also you can get some useful data and stuff here. I'm not going to really dig into it, but the way you would intercept APIs on your phone, for example, is you go up here and you capture request, and then you just turn this on. I'm not going to dig into all that.
Windows is just
Windows is
not.
What? No. So then you just decide on your
it's a
port.
good tool, is if Windows doesn't like it.
And then you just look up the IP address of your machine. You go on your phone, and you'll have to go into the advanced Wi-Fi settings, and you set the proxy to the local IP address of your machine at this port. And then this can automatically start capturing those requests, and you can start analyzing those. Now, not every API is secured, but you will quickly realize that the higher budget APIs will have things that are going to be major roadblocks for you.
Encrypted responses or something like that?
So for example, SSL encryption makes it incredibly difficult. It's not impossible, but it is incredibly difficult to intercept those requests and actually analyze them. That's the biggest hurdle.
Yeah, because it's smart. The whole rest of the internet is already doing that.
Oh yeah, but it's really stupid. For so long, there were multiple apps that I was able to just willy-nilly intercept and be because you're only looking at your own data in this context, right? But that's a security flaw on their end too, because if you had Wireshark open or something like that at a coffee shop, you could be intercepting those app requests and stuff like that, and potentially be learning devastating information about people. The other thing that gets really annoying to deal with are things like cookie and authentication tokens.
Yes, I hate authentication tokens.
So Postman can help you deal with cookies. You have these cookie settings here that you can fool around with and add cookies. And a lot of times, when you're dealing with Google Maps or the Twitch API, you'll have authentication tokens that you have to authenticate 80 or 90% of the requests you send. So a lot of times, APIs will have a few requests that you can get just some general data with just the simple requests, but then to get more detailed information, you need to authenticate. And you can certainly do that in Python and requests, but it gets nasty quick.
Yeah.
And that's where usually there'll be one request that you have to send your username and password in, and then you get an authentication token back that's valid for a certain period of time. And that also kind of gets to something I was going to mention too, is I remember before y'all, printing the response, right? That you're getting from the Python library. I think y'all were getting oh wait, no, wrong one. wrong. You get the response 200, right?
Yeah, if you don't actually request anything inside the data, it just gives you the result.
Well, no. So actually, no, that's the full JSON data there in that variable, but by default, it's just printing that response. And when you're doing this coding, and especially discovering the API for the first time, it can be really useful to print that response, because then you'll know, like, if you get a 400 error or a 404 error, like what's actually happening. And then from there, then you just tack on the .json. Oh, no, I don't even know how to spell JSON. And then you see that that object actually does, in fact, have the JSON data in it. So it can be useful to like print the response, and just because that's where you could easily have a loop that's like, continue if you have a 200, but if you don't, spit out this error and be like, hey, your program failed here. Definitely build in debugging when you're reverse engineering these APIs. You'll save yourself a lot of time.
Yeah, I'm already playing with Postman and just putting in like a LA Public City
We can
data source.
switch to yours.
God. Yeah, sure, great. Let's not.
Yeah.
And we've already done it.
Oh, sorry, I can switch it.
Yeah, it's fine. So I just went ahead and put this in the same way that you did. I went to a that's PyCharm. I went here. I just did a response. I went into the inspect element. I went to network. I reloaded it. I got the 200 here. I right mouse clicked on it. I went to
copy.
see. I am paying attention.
Yeah.
Copy as curl. Then I went into Postman. I was just like, import that as raw text. Put it in here. Great. Looks good. Continue. Import, and boom.
Yeah. And
so then I click on send. It gets a response. I'm able to look at it, and I can also see there's like other fields here.
Yeah.
I can see raw. I can see pretty, preview, whatever. But it doesn't let me visualize it.
Yeah.
But when I look at
That
the
might be a paid
responses,
feature.
well, maybe. When I look at the responses, I can also start to see information about other fields. So what I thought was cool is like here, if I look at the response headers, I can see that there might be things I could pivot on, and I can already see how, like, if I didn't know anything about this API, I already know that it responds with these things, therefore they might be searchable as well.
Exactly.
So all these other fields that like give me other access into the API, maybe they're pivotable. Maybe I can like take one piece of data, search, and then use the response to learn other types of data I can search as well. So it even tells me, I noticed the type of data. So I can see it's text, text. Yeah, and I think there was one number, floating timestamp, text, location.
Ooh.
Yeah. So like there's a lot of different things here that's formatted differently. If I discovered that there was like a list here instead of like text, then maybe I could do that thing that you did. But really what's cool about this program is being able to just like find a data source, have no idea what it's doing, rip a request out of just a website or something else or an app or something, and then drop it here and start to like take it apart.
And that's what I was saying about the beautiful GUI interface. I'll switch back to my screen, but like there's like authorization up here, and then that's where you can start like working with OAuth 2 and put in access tokens and that stuff. But but
if you're a researcher, if you're a hacker, if you're doing bug bounties, if you're doing any of this stuff and you want to have access to these data sources, probe them for vulnerabilities, or just extract the right data in like an easy format, then this is a way that you can start working with some of these APIs that may not be publicly documented in the way that would be optimal for getting started. So last time we went over stuff that was optimal. So like, okay, there's a whole documentation available for you that has like nice examples and stuff. If that is not the case and you're dealing with just some random app on your phone or something you're doing a bug bounty on, or maybe a data source that just has terrible documentation but is still public, then this is how we can start to use some tools that take it from like what looks like rocket science to like some GUI stuff where we're just copying and pasting and really like getting started with it very quickly.
And to be clear, there are various Python tools and stuff on GitHub that you can use to help enumerate or expand on these APIs, because oftentimes you'll find like once you find one request, then like where the API URL is, and then you can start like a lot of these tools will just like brute force a bunch of different things that are normal. So like users or like various
fields that are expected.
Fields that are commonly used, and so then you can find out stuff like that. And that's how you would usually find fields that maybe like the developer put in API calls for themselves to make their lives easier and convenient. but they never intended the app to have access to
Right,
or
or like
use.
features that were in test and then like somehow got to production. And
Yeah,
like, people
because
didn't
that
sign
would
off on
never
it.
happen.
Of course not.
Yeah,
Yeah, or things that were sunsetted and never officially removed.
yeah, exactly.
Yeah, we know a lot about that. In fact, one of the projects I'm working on that's Wi-Fi based is only possible because someone, our German friend Stefan,
Yeah.
found out an old API feature that had been left that allowed him to do all this great stuff.
Oh yeah.
So APIs are super useful.
That's the
Hardware,
problem with-
software, like
Yeah.
yeah.
Problem with legacy support is that you do have to leave a lot of those features in. So like, I remember like there was one API that I was utilizing that eventually did turn on SSL certificates, but I had already decoded their API beforehand, and I had already gotten I figured out my own access token. So even after they turned on SSL, I was still able to utilize their API fully, despite the fact that if I had tried it again, it would have been nigh on impossible for me.
Interesting. So basically, like you were able to go in, decode the API, figure out how it works,
Yeah.
and then they shut it down. So it would have been much
Yeah.
harder. But at that point, you already
Yeah,
knew how it worked.
I actually happen to know that company hired a security engineer to lock their app down, and
because
yeah,
they got in trouble.
yeah,
yep,
exactly. So yeah, it's all fun stuff for sure.
Where would you recommend people go to check out more of this stuff? Besides Postman, like any other resources you'd recommend for first-time
Postman and
API
Fiddler are very good options.
Hmm.
If you do Google around, you'll find some good blogs on like Medium and other sources like that on reverse engineering APIs. You can also go to websites like Kitploit and other GitHub aggregation websites and look for anything that involves API. And oftentimes that's where you're going to find the tools that are intended to expand on an API that you maybe already kind of discovered or help you find that kind of stuff. And then also, like, if you really want to get deep down into weeds, then you would start investigating, like, how to intercept SSL certificates and, like, self-sign SSL certificates and, like, I authorize myself to see this kind of stuff, which... can sometimes work.
Cool. All right. Well, if you want to get started, then definitely check out those resources. Did you know that the Thug Crowd people just like do not like Kitploit?
Really?
Yeah, they hate them because they run ads and they don't put any work into their descriptions.
You know. But look,
Yeah.
I just find
They have an alternative,
Yeah.
but it involves a curse word, so I can't say it on the show.
Oh wow, that's really
Helpful.
sad. Yeah, it's like, but no, Kitploit is like a really cool website if you're just looking for tools.
Yeah,
Like-
don't expect you're gonna learn anything.
Yeah, you're
special
not
about
gonna
the
learn
tool.
anything.
It's just an aggregator. But
Yeah.
if you're looking for cool new stuff, then GitHub, and also I would say like bug crowd resources. A lot of people who do bug bounty stuff will use these same sort of tools to understand how websites work. So you'll probably find a lot of really great resources around people that do bug bounties as well, because this is one of the things people do when they get started.
Yeah, absolutely. No, this is actually how I got started in hacking, right? Is like I essentially wanted to be my own big brother and like have that's seriously like the question. I was like, we always talk about big brother and like big data and stuff, but like how easy is that actually to gather and analyze? And it was at the time and in the context I was doing it, very scary, like how easily it was to be big brother. And that was because of like that thing I described before where I was able to completely bypass all the paywalls on their data and just get all their data arbitrarily.
I am so proud of you for going this entire live stream without saying the name of the company once.
Oh, yeah,
Thank you
yeah,
so
yeah,
much
yeah.
for that. I
Yeah,
cannot say enough.
exactly.
All right, let's wrap it up before we slip up
Yeah.
and say. Thank you so much for joining us today to explore APIs and other cool hacking stuff. We have to give a big shout out to Varonis for making this happen. If you want to see this show continue, please make sure to like, subscribe, check out the Security Forward, that's Security FWD YouTube channel, where we have all of these archives so you can see any of the ones that we broadcasted at any time. And also check out the PowerShell Attack Lab with Varonis. It's a great way to see how even if hackers like us get into a system, we can still be caught with some awesome modern technology. So definitely check that out. Check out the YouTube channel, and hopefully we see you guys next week. We're going to be live every Tuesday and Friday, so I hope we will see you then.
See you then.
Bye.
Bye.